بسم الله
دكتور في
الرحمن
علينا assignment معين نخلصه
الرحيم.
ولا لا؟
Of course, we have a specific course that we have to finish. We have a collection of slides. I have to finish them because they are important to understand the cryptography. Yeah, they are all important. Even I skip many things. For example, this introduction to number theory was about 70 slides. I compacted them to less than 40, just to make the most important concepts in number theory. So I try to minimize everything. For example, mostly the next slides maybe not more than 30 slides only. But this one is also just because it contains many concepts that can be skimmed very quickly. Okay, so we start by introduction to number theory, and the first thing is the divisibility. The first thing is divisibility. Okay. Divisibility means that some numbers divide others. For example, 4 divide 8. This sign means divide. Divide means that there are no remainders. There is no remainder. If I divide 8 by 4, there is no remainder. This means 4 divides 8. And 2 divides 4. And 3 divides 12. And 4 divides 12, and so on. And if you can, yes?
ما فهمت كيف يعني 3 divide 12 كيف يعني؟
3 divides 12 means there is no remainder after division. If you divide 12 by 3, it will result in 4 without any remainder. No remainder. No
okay.
remainder, you know? Remainder.
okay.
Remainder is equal 0. There is no remainder. So if 3 divides 12, this means there is no remainder. Remainder is 0. Okay, and for this is divisibility. The first thing that you should know about number theory is divisibility, to know which number divides which number. Okay, so the divisibility has some properties. For example, if A divides 1, this means A equal plus or minus 1. There is no way that this number is greater than 1. Because if A divides 1, this means A equal plus or minus 1. And also if A divides B and B divides A, there is no way unless that A equal B, plus or minus B. I will not care about minus too much. I just care about positive number. So don't worry about how to calculate for negative. Just take care of the positive numbers. So if A divides B, and B divides A, this means A equal or equal plus or minus B. For example, if I have 3, if I have 12, 4 divides 12, 12, I cannot say that 12 divides 4. I can say only that 4 divides 4. Because if I want to swap numbers, they will not be working right. They will not divide each other. The only way that they can divide each other if I swap them, if they are equal. This is the only case that they can work. I can swap them. So this is divisibility, and it has some properties. For example, if if A divides G and B divides H, then B divides Mg plus Nh. Okay? How is this happening? I will tell you an example. For example, if 3 divides 12 and 3 divides 6, okay? And we can write 3 divides anything multiplied by 12 plus anything multiplied by 6. Anything. I can write here anything, and then this relationship will work. For example, 3 divides, I put 1 here. So 1 by 12 plus, and also I put 1 here, 1 by 6. This means 3 divides 12 plus 6, which is 18. So it's working. Because 3 multiplied by 6 equal 18. There is no remainder. So 3 divides 18. If I change anything, I put any number here, this relation is working. This relation is okay. So here, 3 divides 18, this is going to work because M here is 1 and N here is 1. I can put other numbers. For example, I can put 1 here and 2 here. So for example, 3 divides 1 by 12 plus N, I make it 2. Any number is okay, it will work. So it is 12 plus 12, which is 24. Okay, 24, 3 divides 24. Okay, this is the properties of divisibility. Okay, so there are also, we have, if you have any question, just please wait for, I will tell you when I'm ready to receive your question. I know that you see many different new concepts, but just wait for a time, maybe it will be clear after that. We finished the divisibility, we move to division algorithm. Division algorithm. Division algorithm is very straightforward. It says you can write the number A as number multiplied by N plus R. This means this is R, which is remainder. For example, I can write 13 as 3 by 4 plus 1. I can write, for example, 15 as 3 by 5 equals 0. And I can write 17 as 17 maybe 2 by 8 plus 1. This is the remainder after this multiplication. Okay. I can say if these are cycles. So for example, I have 24 hours. I can say 13 equal 1 by 12 plus 1. 1 by 12 plus 1. If this is 13 means 1 p.m. 4 o'clock. So if I have this is a clock, and then I have one round start from here. One round is 12. This is 12, one round. And then if I get another round, I will stop here because this is 12. I stop here at 1 o'clock. Because if I'm counting for the second round, I will stop here because I have 12, one round of 12 plus 1. Okay. This, if this is an o'clock, so this is going to have cycles, repeated cycles. And the remainder is the last cycle position, the last cycle position. I can also make it on the number line. For example, this number line, 0, I can take the 12 or 15. Okay, if I take 15, this means this is going to have 13, 30, and this is going to have 45, and this is going to be 60, and this is going to have to be 75. Okay, and if I want to talk about 70, I can write 70 as 4 by 15 plus 10. So I have 4 rounds of 15. I have here 4 rounds of 15. I'm rounding, but 15, not 12 at this time. I'm rounding 4 times with 15 and then add another 10. You can say I have the first round here, the second round here, the third round here, the fourth round here, and plus 10. I have also 10 here. This is the remainder. So this is the first cycle, the second cycle, the third cycle, and the fourth cycle, 4. 1, 2, 3, 4, this is 4. And 15, this is the period. And this is the remainder because I have here 16, 60, this is 70. So the distance here is 10. It's the remainder.
دكتور طب عندي سؤال.
Okay.
الحين لو كان مكان ال70 كان رقم 30 بنحط مثلا 2 ضرب 15 انه عشان مشينا مثلا على الخط الثاني ولا بنحط 1 ضرب 15 بلس 25.
Yes, if you have a period of 15, you have a period of 15. So this is the only way to write 30 is 2 by 15 plus 0. 2 by 15
اوكي
plus 0. Yes, because you don't have a remainder.
طب هو خط الاعداد اللي تحت هذا بتغير كل مره ولا انت بتعطينا اياه ولا كيف؟ ولا احنا بنكتبه من عنا؟
Okay, don't worry about how I ask you. I just want you to understand what I'm saying. Okay? Don't worry about the way I ask you because you will see homework, you will see questions. Okay, so when it comes to questions, I will tell you how to answer them. But for now, I just want you to understand how this is done. Everything I'm writing, you understand it. Okay?
Okay.
So this is the how to write any number in as a multiplicand of some number and plus the remainder. Okay, just before moving to the different section, anybody has a question? Anybody want to ask any question?
Doctor, here it will be in order, right? It cannot be reversed. Like we cannot say 2 multiply 30 plus 15.
No, you cannot. No, you cannot have it. You cannot have it this way because the number will be greater than the result.
No, on 70, doctor. I mean, you see, it is 4 multiply 15, right? If we say
4 multiply,
yeah, if you say 2 multiply 30.
2, okay.
Plus
you want
10. Is it possible? Plus 10. Is it possible?
Yeah, it is possible, but this way, the cycle, you will not have the cycle of 15. You will have a cycle of 30. This is different.
Okay.
This is different
Yes,
cycle. This is, for example, this is 15 cycle. It's like that, but this is bigger than it. This is 30.
So the condition is 15 here, right?
Yeah, yeah, it's 15. So the cycle is 15. It's a cycle. So the cycle value is 15. But if the cycle value is 30, this is going to be 2 multiplied by 30 plus 10. Okay.
واضح دكتور.
Any other question? Okay. I will go along this way. I will stop and let you ask. So please, if you have a question, just write down it, and then when I stop, you tell me your question. Okay. Anybody knows about the greatest common divisor?
Okay.
The greatest common divisor. Anybody hear this word before? The greatest common divisor. This is for my son in the primary school. He studied this greatest common divisor. In the primary school, they studied. I studied even in the primary school. The greatest.
العامل المشترك الأكبر.
What?
العامل المشترك صح الأكبر ولا؟
Yes, exactly. Yes, exactly. So you know about it. The greatest common divisor, you can say GCD, just for abbreviation of, for example, we can take an example here, like 12 and 18. 12 and 18. Do you know the greatest common divisor of these? For me, I can try an algorithm. The algorithm is Euclidean algorithm. This is algorithm, they make it, they apply it on computer to get the greatest common divisor. And for lecture 2, I showed you how to use the greatest common divisor between two numbers to be able to create a private key for the RSA. So greatest common divisor can be obtained like that. You can write the biggest number here, 18. 18 equal how much of 12? How much of 12? If I multiply 2 by 12, it's going to be 24. But it is 24 is greater than 18. So the only way is 1 multiplied by 12 plus?
Yeah, plus 6.
Yeah, plus 6. I get 12 here. And how the 12 is how many of 6? How many of 6? It is 2 by 6 plus 0. So the greatest common divisor of these two numbers is 6. The greatest common divisor, this is our algorithm. We make it different way for I make it, I teach my son, I teach him in different way, but we do it like using the Euclidean algorithm. Because when you want to write computer algorithm, so the only way to have is to have an algorithm for this. Okay, let me take another example. Let me take another example. If I want to get the greatest common divisor of 15 and 26. So I take the biggest number. I take the biggest number, which is 26. Is how many of 15? I can say, okay. Yeah, the only one is 1 by 15, exactly. And the remainder is what? Is 11. Remainder is 11. So I take 15 here, and I see 15 is how much of 11? Is 1 by 11, okay? Plus 4. Because if you sum 11 plus 4 equal 15. So I take Again, I take 11 here, and I see 11 is how much of 4? Is 2 by 4 plus 2. 2 by 4 plus 3, not by 2. So 2 by 4 is 8 plus 3 is equal 11. And also I continue the procedure. So I take 4 here. 4 is how much of 3? Is 1 multiplied by 3 equal 1, plus 1. I take 3 here. 3 is how much of 1? 3 by 1 plus 0. So I have here the greatest common divisor is 1. So the greatest common divisor of 15 and 26 is 1. The greatest common divisor is 1. This means these two numbers, they call them, if the result is 1, they call it another name, which is co-prime. Co-prime. This is another name for the GCD equal 1. If the GCD equal 1, this means these two numbers are co-prime. Co-prime means they don't divide each other. No one of them divide the other. Okay. Okay, let me take another third example.
Doctor,
yes.
Why is it 1?
Because in our procedure, I want to find the greatest common divisor between 15 and 26. I apply the algorithm. I go down until I find 0. Before 0, this is the greatest common divisor. The remainder equal 1. When the
دكتور طيب ليش
other than okay. Go ahead.
عند 4 ليه ما عملناش 1 ضرب 4 زائد 0 وخلاص؟
عند
4.
No, because
1 ضرب 4 زائد 0.
Yeah, I have to get the multiplicand of the previous step. I cannot. I have to use the previous step values. I cannot use my own values.
Okay.
Okay. So
I got it. Thank you.
Okay. So I have here 1. This is the remainder. The last remainder other than 0. This is the greatest common divisor. If the greatest common divisor is 1, this means they are co-prime. Co-prime means no one of them divides the other. So I cannot say 2 multiplied by 15 equal 30. If 15 and 30, they are not co-prime because they have common number. So they don't have common number here, and they are co-prime. There is another interesting example in the slides. What about the greatest common divisors of bigger number, 710 and 310? I take the biggest number, which is 710, equal how many of 300s? I can say this is 2, because if I multiply by 3, it's going to be 900s. But I want it less than or equal 710. So the only way is to have it is 2 multiplied by 310 plus, if I multiply 2 by 310, I have to get the result of this, which is 0.
90.
Yeah, 620, right? 620 out of 710 is going to
plus 90.
Yeah, plus 90. If you add 610 plus 90 is going to have 710, okay? And I get 310 here. I put it here. And then how many, 310 is how many of 90? It is 3 by 90.
4.
Okay. 3 by 90 is 3. This is going to have 3 by 9 is
40.
plus 40. If you add 40 here, it's going to have 310. So plus 40. If you add these two numbers, it's going to give us here 310. So I get 90 the same way. 90 is how many of 40? This is very straightforward because it is 2 by 40 equal 80 plus 10. I get 40 here, and see 40 is how many of 10? It is 4 multiplied by 10 plus 0. This means, okay, I get the result here because I get remainder equals 0. This means I finished the algorithm. If I finish the algorithm, this means this remainder is the greatest common divisor. So the greatest common divisor of 710 and 310 equal 10. This is the greatest common divisor of these two big numbers. Okay, any question? Any question in this part? Okay.
Doctor, there's one student want to join the meeting.
Okay. I don't have anybody in the waiting list.
Okay.
You can, okay, you can send him the meeting link. Just to try again. Because I don't have anybody in the waiting room. Let me check again. Yes, nobody in the waiting room.
Doctor,
Okay,
can
now,
we calculate, Doctor?
Yes.
Can we calculate it by the calculator?
The greatest common divisor?
Yes. Do we have any method?
By calculator? I don't think so, but I will tell you another way using prime numbers. I will tell you another way to calculate the greatest common divisor by the prime numbers. What we are doing here is just to make something can be programmed on the computer. Maybe there is another ways. For example, you can just look at the numbers and you know what is the greatest common divisor. I don't want somebody to use it, a method somebody use it, but I want a method computer use it. So this is different. Maybe you will find many methods to find the greatest common divisor, but some of these methods may not work as an algorithm on the computer. That's why we are applying, because we will deal with big numbers. If you deal with big numbers, the normal or the manual methods will not work with those big numbers. Okay, so let's go or move to another topic, which is modular arithmetic. Modular arithmetic. The modular arithmetic is talking about the remainder only. Just care about the remainder. For example, if I say 13 mod 6 equal 1, just because if I multiply 6 by 2 is going to have 12, and the difference between 12 and 13 is 1. So this is the remainder. In modular arithmetic, we don't care about the result. We just care about the remainders. Everything about remainders. Nothing else, just remainders. So for example, if I have I'm using the remainder theorem, I say, okay, A can be written as Q multiplied by N plus R, and R is between 0 and N, and Q is the root of this division, which is A over N. Let's take an example. If I take this, for example, those two numbers, 13 equal 2 by 12 plus 1. 2 by 12 means I have R here equal 1 and Q here is Q equal 13 over 12. The floor, you know the floor of 3 by 12. This is going to give us 1. Sorry, 13 by 2, no. This is Q. Q is here. So it's going to 13 by, okay, just give me a second. I'm confused here. Just because 2 multiplied by 12 equal plus 1.
6 and remain 1, Doctor?
The remainder is 1, okay? And which one is the division of one another?
6.
No. 2, we have 2 multiplied by 12. Yeah, I have a mistake here. Yes.
المفروض 1 ضرب 12 صح؟
Yeah, this is not 2 but multiplied by 12. It is 1 multiplied
by 12.
Oh no, 2 multiplied by 6. Yeah, 2 multiplied by 6 plus 1, right? So the mistake here, I just used the wrong formula. Okay, now I can find that 2 is called Q, and that one is called N. And the N here is, if you remember the cycles, and the Q, I can get Q as a floor of this division, which is 13 by 6. The floor means, you know, the floor of 1.5 is 1, just to get the nearest integer, less than 1.5. If you remember the floor and ceiling, the ceiling is different compared to floor. The ceiling is 2 here. It is the biggest integer greater than 1. The next integer greater than 1.5, which is 2. So this is the ceiling, and this is the floor. So Q here is the floor of 13 over 6. And this way we can write any number as this formula, as we said in the remainder theory. Let us move to something else, is called congruent. Congruent. We are going to use, yes.
ممكن تشوف إذا في حد في الويتنج ليست لأن ياس تحاول تدخل ما تقدر.
لا ما في, nobody in the waiting list, nobody in waiting room. Okay, okay, let me. Okay, I think she can wait. She can wait, or he or she.
في دكتور.
He can wait for the after I finish the lecture. There is no way. I cannot stop the lecture right now.
Okay.
Okay, just
Okay.
wait for next session.
Okay.
And I'm trying to record this, but I'm not sure if it is working. I'm trying to record it on my device, so I can send you a link for the lecture. But just take note of his name, and I will make him attend. Okay.
Okay, doctor.
Okay. So for congruent mathematics, I can say 73 as an example. I should stop this, okay? 73 is congruent with, you can say, okay, just forget about this number. Congruent is another way of writing modulus. You know, in some programming language, we use mod. Okay, as we see here, 13 mod 6 equal 1. We can use it like that. Some programming language use it this way. But we have here another sign which is called congruent. Is a 3 lines like this. These 3 lines can describe the remainder, and they can describe our remainder theorem. For example, I can say that 73 is congruent with 4, and I open this bracket and write mod 23. Yes, I have Hagar Mahmoud entering the waiting room right now. 23. I will find another way to skip this waiting room because it is annoying, really. Okay, so now why is yes?
In the settings, you can remove waiting room, meeting settings.
I cannot now. Zoom has changed the settings. Either you use passcode. I will change it to passcode. Either you use passcode or waiting room. You have to use one right now. They changed the setting for the entire Zoom accounts.
دكتور أنا النت عندي فصل، حاولت أدخل كذا مرة كان مش راضي يدخلني.
Okay, no problem. Now is okay, no problem.
أوكي شكرا.
Okay. So we have, we can say congruent. This word here is represented by these 3 lines. What is the meaning of congruent here? It means that 23 divides, okay, I have another, okay, admit. 23 divides 73 minus 4. Okay, if you see this is minus 4 is like this, okay? And if you multiply 3 by 23 is going to give me 6, 9. This is congruent. So if
دكتور why 3 هي عشان يكون نفس الجواب. اوكي.
no, okay. Can you repeat your question, please? Okay, okay.
Doctor, I don't understand.
There is another. This is another way of writing the modulus. Another way of writing the modulus, the remainder and the modulus. This is another way, just to make sure that the difference between 73 and 4 is the 23 divides that difference. Okay, you understand this point?
دكتور أنا صراحة ما فهمتها.
Okay, this is okay. You have the same shock when somebody hear about congruent for the first time. I can write, for example, I told you about writing 13 mod 6 equal 1. Okay, I can write 13 mod 6 equal 1 in another way. How to write this? I can write mod 6 here.
دكتور ما نشوف الورقة.
Okay, sorry. Yeah, I'm not looking at the screen. Okay, mod 6 here. Okay, and I have to make sure that the difference between these two, which is 13 and 1, 6 divides that difference. So that difference is 13 minus 1, which is 12. 12 divides 6, so it's okay. So this relation is okay. This relation is the same as this one, but in different way. 13 mod 6 equal 1. This is the same as 13 is congruent with 1 mod 6. It is just a different way of writing. At the beginning, I told you about the C++ way of writing the mod. So this is just a different way of writing the modulus arithmetic. It's just by using the congruent. Congruent means I have a mod 6 here. I have to make sure that the difference between these two, 6 divides that difference. It means that 6 divides 13 minus 1. It's okay because 6 divides 12. Okay? This is another way of writing the congruent mathematics. The congruent mathematics has some properties just like the normal arithmetic. For example, if A is congruent with B mod N, as I told you, this means N divides A minus B. This is the first property. The second one is A congruent with B mod N. This means I can change these two. I can change the position of these two because the difference will be the same. I know you may say that the difference may be negative, but there is a modulus for the negative 2. So don't worry about the negative. For example, I have talked with you about 13 and 1. If you swap them, it's going to have 1 and 13. And the difference is minus 12. Minus 12 has a modulus over 6 too. Yes, it works. Okay. So if you swap them, this means that B is congruent with A mod N. This is going to have the same thing. Another property is if A is congruent with B mod N and B is congruent with C mod N, this means B is congruent, or A is congruent with C because it's a transitive. So A is congruent with C mod N. A, if I say A, B, and then B, C. So this means A, C. This means A is congruent with C mod N. Okay. Maybe I can take an example. I will try with you. I don't have an example in my mind, but I will try to have an example for this. Okay, let me talk about, let's take very simple. If A is and B the same thing is congruent. Okay. So I can take 8 and 4. Okay, mod 4 is working because 8 minus 4 is 4 and 4 divides 4. And another example is 4. I take this 4 here and the congruent with how much? 0 mod, but 0 is not a good question. It's not a good example. I can change it. It's working, but 0 is not a good example here. I have to change this. It's not going to have mod 4. Okay, 9 is congruent with 7 mod 7. And 7 is congruent with, this is going to have 0, 2. But it's going to have 14, if I say like that, 14 mod 7. This means 9 is congruent, this one is congruent with 14 mod 7. Okay, because, okay, let me check this with you. Because 7 divides the difference between 9 and 14. The difference between 9 and 14, yeah, this is not true. This is not, I told you about this is not a good example. Yeah, because the difference here is not divisible by 7. So this is not good example. Okay, I don't have an example in my mind. I will give you an example next lecture. I don't want to waste more time.
أصلا مش فاهمة هاي الشغلة اللي حكيتها قبل شوي.
المودulus or congruent. The congruent is easy. Just to make sure that you understand. Just make sure that you understand this one. For now, make sure you understand this. Okay?
Doctor, can you briefly repeat it, please?
دكتور فيك تعيدها آخر مرة؟
Okay.
دكتور شوي.
I know. Yes. It's like eating something very hard to eat. Okay. So I know, okay. Because everything here is just the opposite of the way that you make calculations. You just make calculations and care about the result. Here, we don't care about the result, we care about the remainder. So that's why, okay? The congruent is just, okay, let me take that example from the papers. That example is okay. 73 is congruent with 4 mod 23. What does this mean? What does this mean? It means that I have the mod here, which is 23. I told you about this is a cycle. These are cycles. And I know that if I write it this way, I know that 23 divides the difference between these two, 73 minus 4. Why it is divides? The divides means that if I divide this number by that number means it will not have a remainder. The remainder is 0. So 23 divides 69. Just because if you multiply 3 by 23 is going to give us 69. This means the remainder is 0. After this division, no remainder. This is a condition of the congruent. I have to make sure that this number divides the difference between these two numbers. Okay, now is okay? You understand the congruent right now? We still have a
Yes, doctor.
We still have a challenge. We still have very challenging properties here. Okay, let me move. Okay, just remind me next lecture. I will give you an example of the last property. I don't have an example in my mind. Even in the book they don't have examples. Okay.
دكتور طلب صغير بس.
اتفضل.
ممكن بس تخلص الليكتشر المحاضرة وتصور كل اللي كتبته وتنزله على الكلاس روم.
اوكي.
يعني كل اللي كتبته صوره ونزلنا اياه على الكلاس روم عشان نراجعه.
I think this is a good idea, but you know, it is just, you know, I am writing and then reverse back like that. You know how.
مش مشكلة دكتور، ما احنا فاهمين انت شو سويت وشو ما سويت، بس احنا بدنا هذا الورق عشان نرجع يعني ندرس
عشان
منه.
نفهم ونراجع. احنا فاهمين اللي انت كتبته بس عشان نراجع ونعرف.
Okay, but I will not give you this paper. Okay.
No
exactly
problem.
this paper, because it maybe is the okay. So remind me, next lecture I will tell you an example for the last point. The last point is important because we will need in future class. Okay. Actually, there are there are many. I think it gives me here. Okay. Let me move to next slide. There is some, I told you about these 1, 2, 3. Okay, let me move to another paper just to get rid of this one. And there's 1, 2, 3 other properties. The same thing, but for 2 modulus. For example, if I have A mod MOD, mod N plus B mod N, all of these mod N, I can have A plus B mod N. This is exactly as A plus B mod N. This is the same properties. If you study any mathematics at the first time, they asking you, they are telling you, for example, if you say 3 plus 2 multiplied by 5 equal 20. This means I can write it this way. I can multiply 3 by 4 plus 2 by 4. 2 by 4. This means 12 plus 8, which is the same result, which is 20. Okay, this is called distribution property. I can distribute a number on the sum. Here, I can distribute the mod on the sum. I can also distribute the mod on the sum. Okay. Let's have an example for the first property. For example, if I have number here is 11 mod 8. 11 mod 8. Anybody can tell me 11 mod 8, how many? How much? 11 mod 8. The remainder of division, 11 is dividing 11 by 8. How many? 3. Okay.
3.
Yes, exactly. So 11 mod 8 is 3. And 15 mod 8 is 7. Okay? 15 mod 8 is 7. I can write this as the same thing as like that. Okay, let me write it this way. 11 mod 8 plus 15 mod 8. All mod 8. It's equal to 3 plus 7 all mod 8, which is equal to 10 mod 8, which is 2. The result is 2. If I do it like, I know that 3 plus 7 here, because this is 3 and this is 7. If I sum 3 plus 7, this is going to give me 10, and 10 mod 8 equal 2. The difference between dividing 10 by 8. It will give a remainder of 2. Okay, I can have another properties. The second one, you can have the same properties for plus and for minus. The same thing for minus A mod N minus B mod N. All mod N is the same as A minus B mod N. Okay, and for multiplication too, you can have A mod N multiplied by B mod N is this, all mod N is the same as A multiplied by B mod N. These are the 3 properties that I want to tell you. If you open the slides, you can have example for each case. It's very straightforward, no problem in it. Now I want you to construct table. Construct modulo 8 table. Modulo 8 table. I want to make it for, okay, you can understand how summation is done. Okay, let me do summation for you. Summation modulo 8. What is the summation modulo 8? Okay, if I want to construct this table, is very straightforward too. You can take it like that: 0, 1, 2, 3, 4, 5, 6, 7, and only 7, because any if I get to 8, so 8 mod 8 means 0, so I return back to 0. There is no 8 here. It is from 0 to 7. Okay, and I write the same numbers here: 0, 1, 2, 3, 4, 5, 6, 7. And here I can say plus modulo 7, modulo 8. Take care, everything I have to make sure it is the remainder after the division by 8. Don't forget about this. 0 plus 0 equals 0. 0 plus 1 equals 1. 0 plus 2 equals 2. 3, 4. I just sum 0 to these numbers, so it's going to have the same numbers here: 5, 6, 7. What about 1? If I add 1 to 1, this is going to have 1 to 0 is going to have 1. And 1 to 1 is going to have 2. 1 to 3, 2 to 2 is 3. Plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. 6 plus 1 equals 7. 7 equal 1 equal 8. But I'm not talking about 8. 8 modulo 8, which is 0. Okay, take care of this, because you have an assignment. You will construct modulo tables. Okay, let's move to if you don't understand these 2 rows, you can understand the third one. Just add 0 to 2. This is going to have 2. Okay, let me have lines here, not to be confused. So 2 by 0 is equal 2. 2 is added to 1 equal 3. 2 is added to 2 equal 4. 2 is added to 3 is equal 5. 2 is added to 4 is equal 6. 2 is added to 5 is equal 7. 2 is added to 6 equal 8. 8 modulo 8 equals 0. So I'm going to have 0 again. And the 2 is added to 7 is equal 9. 9 modulo 8 is equal 1. 9 mod 8 equal 1. Okay, now I understand the pattern. I can complete the remaining part of the table without any problem, because this is 1, 0, 1, 2, 3, like that. 0, 1, 2, 3, the same. There is some kind of symmetry in the table. I can write here 3, 4, 5, 6, 7, 0, 1, 2. 4, 5, 6, 7, 0, 1, 2, 3. 5, 6, 7, 0, 1, 2, 3, 4. Okay, and here 6, 7, 0, 1, 2, 3, 4, 5. And here we have 7, okay, 0, 1, 2, 3, 4, 5, 6. This is the modulo 8 addition. I can also construct the modulo 8 multiplication. Okay. I'll just give you an example of multiplication, and you can construct the remaining part of this table. Multiplication, like I have multiplication here. I have 0, 1, 2, 3, 4, 5. Don't forget, this is mod 8 table. Mod 8 table. Of course, I can have mod 7 table, mod 9 table. Anything is okay, but I have here mod 8 table as an example. 5, 6, 7. I have also here 0, 1, 2, 3, 4, 5, 6, 7. Multiplication means I multiply 0 by anything. This is going to give me 0, 0, multiplied by 1, 0, 0, 0. Anything multiplied by 0 is equal 0. What about 1 multiplied by 0 is equal 0, multiplied by 1 is equal 1, 2, 3, 4, 5, 6, 7. What about 2? 2 by 0 is equal 0. Take care of this. 1 by 2 is equal 2. 2 by 2 is equal 4. 2 by 3 is equal 6. 2 by 4 is equal 8. 8 modulo 8 is equal 0. So we start here to just, this is not normal arithmetic. This is not normal arithmetic. Just given us 0 if I multiply 2 by 4. Because 2 by 4 is equal 8, mod 8 equals 0. 2 by 5 is equal 10. 10 mod 8 is equal 2. And then the same sequence repeats. So this is 2 by 6 is 12. Out of this is equal 4. And then this is 6. You can complete the table this way. You can complete the table. Okay. Let me check. Let me check how many.
Doctor,
Yes.
after 0, 2, 4, 6, how we got it?
This one here.
Yes. Yes.
If you multiply 2 by 5, 2 by 5 is 10. 10 mod 8 means the remainder after dividing 10 by 8. So if I divide 10 by 8, it's going to give me a remainder which is 2. Remainder is 2. I don't concentrate on the result. Yes.
Yeah, I got it.
And also for 6 multiplied by 2 is equal 12. 12 mod 8 is equal 4 because I have a difference between 8 and 12, which is 4. So I write 4 here. 2 multiplied by 7 is 14, and 14 have a difference between 8 and 14, which is 6. So I write 6 here. Okay, and there is very important property here, just to make sure that this mathematics is the same as normal mathematics. Everything here, we saw how distribution is done, also how to make summation, how to make multiplication. There is something very important in modulus arithmetic and in cryptography, which is additive. We are going to use it extensively throughout the course. Additive and multiplicative inverse. Okay, let me simplify the problem for you. What is additive inverse? For example, in just linear algebra, if you have x plus 1 equal 3, and you want to get the value of x, what you will do? Just add -1 to the two terminal, to the two equal, to the two right-hand side, to the two sides, right-hand side and left-hand side. So if I add -1 here, and I add -1 here, this is going to give me x plus 1 minus 1 equal 3 minus 1. This is not in cryptography. This is from primary school. I'm not teaching you something new. It is just from primary school. I repeat it for you. And now I can say x, because if I sum them, they will be 0. So x equal 2. So this is the answer for how much is x. What I have done right now, just right now, what I have done, I have added the inverse, the additive inverse of +1. So I have additive inverse, which is for mathematics, for +1, I have inverse, additive inverse. which is -1. What about the multiplicative inverse? Let's take an example. X over 2 equal 4. What is the value of x? To answer such kind of question, you multiply both sides by 2. Why? Because I know that 2x multiplied by 2 to the power -1 equal 4. Because I know this is in the denominator, if I raise it up, it will be -1. I have to write this, both sides by 2. So x multiplied by 2 to the power -1 multiplied by 2 equal 4 multiplied by 2. This is going to have 2 to the power -1 plus 2 to the power +1. This is going to have x 2 to the power 0 equal 8. This is 1. This means this is 1. This is 1. This means x equal 8. What I have done here is just multiply both sides by multiplicative inverse of 2. Okay, I have the multiplicative inverse of 2 is 2 to the power -1, and the multiplicative inverse of 2 to the power -1, which is 2. So vice versa. This is multiplicative inverse of this is 2 to the power -1, and the multiplicative inverse of this is 2. Okay? All of what I said, this is not in our cryptographic course. This is just in the primary school. What I'm doing right now is to have the same thing for modulus arithmetics. I want to have additive and multiplicative inverse. I want to have additive and multiplicative inverse. Okay, let's say for modulo, okay, let's say for modulo 8. Just an example, I take modulo 8. So if I say this is the value 0, 1, 2, 3, 4, 5, 6, 7. Okay. Okay. And what about the W, the -1, the -W? Okay, let me see how to calculate this. So 0, the additive inverse. This is the additive inverse. I have additive and the multiplicative. So this is the additive inverse is 0. The additive inverse of 1 means if here, the additive inverse of any number, if I add them together, this will give us 0, as we have seen. So if I add 0 to 0 is going to give me 0. What about the 1? The inverse of 1 is not -1 as we have in linear algebra. We have here 7. Why is 7? Because if I add 1 plus 7, mod 8 is going to give me 0. Okay? You understand this part?
Doctor, no.
Doctor, no.
No. Everything is no. Okay. Did you understand this part? It's just from the primary school.
Yes, doctor, it's clear.
Okay. I want to do the same thing for this new modulus arithmetic. I know I have a new arithmetic and I want to make everything possible in this arithmetic. I want to make additive inverse like this one. I want to have multiplicative inverse at that one to solve everything. So if I have an x here, I can solve it. I can find the value of x. So to do that, I have to find the additive inverse for modulus arithmetic mod 2. Just an example. Just an example. Mod 2. The multiplication, okay, let's concentrate on additive inverse. If you understand it, it's going to be very easy for you to understand the W minus 1, which is the multiplicative inverse. What is the meaning of additive inverse? For 1, I have additive inverse of -1 because the sum is 0. For 2, I have additive inverse of 2, which is -2. This leads to 0. 100, okay, let's talk about different way. -100 has additive inverse, which is plus minus 100 because the sum will lead to 0. So I want to have number here. If I sum it to 1, will give me 0 mod, will give me, when I have mod 8, it will give me 0. Every time I use mod 8, it gives me 0. For example, here in this example, 1 plus 7 is 8. 8 mod 8. 8 mod 8 means 0 because there is no remainder. If I divide 8 by 8, the remainder is 0. Also, for this one, can you tell me?
6, Doctor.
6.
6, exactly. Why?
6 plus 2
6 plus 2, it's equal 8.
mod 8 0.
Yeah, 8 and 8 mod 8 equals 0. This is very important property because I want to have something. If I add them together, mod 8 will give me 0. This is the additive inverse. Here also, I can complete them, no problem. 5 and 4 and 3 and 2 and 1. This is just very simple. Okay. What about this is more difficult is the multiplicative inverse. It's more difficult to have. Okay. For 1, I don't have a multiplicative inverse. For 0, sorry. For 0, I don't have a multiplicative inverse of 0. What is the multiplicative inverse? If I multiply 2 numbers, this is going to give me 1 in this case, not 0. Just because here I multiply 2 to the power -1 by 2, this gives me 1. The multiplicative inverse means the number, when I multiply it by the current number, will give me 1. So if I multiply, I can't have this property for 0 because if I multiply 0 by anything, it will give me 0. No result will lead to 1. So I don't have a result for, or I don't have an inverse, multiplicative inverse for 0. Of course, this is going to be changed in the next lecture. I will tell you how to find inverses for all of these numbers. But for now, let's take an example. Let's take 3. Let's do it like that. 3 multiplied by how much is congruent?
So we cannot see the paper.
This one? Okay, sorry. Yeah, because the camera is too near the paper, so some parts are skipped. Okay.
It's okay.
What is the number when I multiply it by 3 will give me 1, which is the remainder modulo A.
3 to the power -1?
3 to, yeah, but this is, yeah, okay. Yeah, okay, this is very, very interesting answer because she is now mixing between the primary school mathematics and the modulus arithmetic, okay? You are mixing right now, I don't know your name actually, but anyway, you are mixing right now between the
Hajar.
Yeah, Hajar. Yeah, Hajar, you take care because this is very accurate answer, but not here. It is for the primary mathematics, but not for modulus arithmetic. I want to have a number, when I multiply it by 3, you know, these number minus 1 is going to be divisible by 8. Okay?
3
yeah.
multiplied by 3.
Yeah, exactly.
دكتور ما فهمت.
Yeah, Abdul Basit, you answer? I don't.
محمد علي.
Muhammad Ali, your answer is.
حتى أنا ما فهمت.
Okay, I'll repeat it. I will give you more than one example. Okay, 3 multiplied by 3 is congruent with 1 mod 8.
Doctor, we cannot see the picture, the paper.
Okay.
It is down.
Yeah, it's very. Okay, let me make it near the camera. Now it's okay.
Thank you, Doctor.
Okay, now it's okay. Okay, 3 by 3 is congruent with 1 mod 8. This means is because 8 divides, this is 3 by 3, which is 9 minus 1. 8 divides 8. This is correct. So this is the correct answer, which is 3. So the multiplicative inverse of 3 is 3. Okay, let me take another example. So this paper is finished. Let me have some more paper. Okay, second, please. Now you can see these numbers here. Okay, now it's okay, clear now. So the multiplicative inverse of 3 is 3. Why? Because if I multiply 3 by 3, this is going to be congruent with 1 mod 8. Okay? What about another number? Like, for example, let me see. Okay, let me see. Okay, 5. What about 5? 5, what is the number that when I multiplied by 5 is congruent with 1 mod 8? This is going to give me a remainder of 1. Okay? To answer this question, I have to make sure that when I multiply a number multiplied by 8 will give me some number near this result. I can say, for example,
2.
If I'm okay, let me try. If I say 2 multiplied okay, 2 multiplied by 5 is congruent with mod 8. Let me check if it's true or not. I have to make sure that 8 divides 10 minus 1. 8 divides 9. No, this is not true answer. Just because 8 is not dividing 9. So I try, for example, 4. Okay, 4 multiplied by 5 equal 20 minus 1. I make sure that 8 divides this difference, 8 divides 19. No, this is not true. What about 5 by 5? Okay, 5 by 5 is 25. Okay, let me take care of your screen. 25 is congruent with 1 mod 8. Let me check if this is true or not. I have to make sure that 8 divides 25 minus 1. Yes, exactly. This is true. Okay, now this is true. So the multiplicative inverse of 5 is 5. So I write here the multiplicative inverse of 5 is 5. And the multiplicative inverse of 7 is also 7. And the others, I don't have multiplicative inverse for them. I only have for 1, I think I have 1 is 1, because, okay,
Simple
And for 2, I don't have a multiplicative inverse of it. For 4, I don't have. For 6, I don't have. I only have for 7, for 5, for 3, and for 1. I have a multiplicative inverse for them. Okay. Last slide. I will take this last slide and I will give you a break. I know there's too much information today. I will give you a chance to just take a breath. And
دكتور بس عندي سؤال.
What?
عندي سؤال في ال additive inverse.
Yes.
ما فهمته بالضبط.
Do you understand the additive inverse from the primary school?
Yes.
Can you tell me, just to make sure that you understand the additive inverse?
Yes, tell me. You ask me a question?
Yes, I'm asking you. Can you tell me what is the additive inverse? For example, what is the additive inverse of -2?
2.
2, why?
Because the equal will be 0.
Yeah, exactly. Okay, now you understand. You understand now the additive inverse.
Yes.
Now, if I want to have an additive inverse for 1, this is not going to have -1. I'm not in the primary school mathematics. I'm in the cryptography or number theory. This is different because everything we divide, we get the remainder after division of some number. I have 8 here is the base of my division.
Yes.
So now I want to have a number. If I sum it to 1, will give me 0, mod 8. If I make it mod 8, it will give me 0. For example,
okay.
I take 1 plus 7 is 8. Mod 8 equals 0. So this is 0. It's the same as -1 plus 2 equals 0. So 1 plus 7 equals 0 mod 8. Okay?
Okay. Doctor, also maybe we have more than one inverse.
Exactly, yes. Yes, exactly. Maybe
for example, we can use the 15.
You can use 15, yes, exactly. This is a good question. This is good answer. And thank you for your concentration. This is called the residues. I will just talk about it right now. This is the next slide. It's just to talk about, I can have many numbers here as an inverse of 1. These are the residues of 7. For example, I can, if I say 7 is okay, if I add 8 to 7, and if I add 8 and 8 to 7, if I add 3 8s, 5 8s, and so on, this is going to have the same inverse of 1. This is called the residues. So, okay, let's talk about residues, and thank you. What's your name?
Wasif.
Okay, Wasif, thank you very much. You are concentrating, and thank you very much. Now, here, the last slide here for the before break is just to tell you about the residues. For example, if I take mod 4 as an example, mod 4, okay? I can tell you, for example, if I take an example like that, I know I will not write down what is inside the slides. This is going to just a repetition. You will not understand anything. I will give you an example out of my mind, just because this will make it very easy for you to understand the residue. Okay, let's take an example. 13 is congruent with 9 mod 4. Let's make sure of this. Because 4 divides 13 minus 9, this means 4 divides 4, which is true. Okay, now is okay. I can tell you, I have 4 here, 9 here, I can put, as Wasif said, I can put other numbers, and this equation is working right. For example, I can say, okay, 13, okay, let me take it like that. If I change it 9 by 5, what do you think? So 4 divides the difference between 13 and 5, which is 4, and 5, you can 8. This is true. Yeah, exactly. This is true. But by the way, I am not good in just the primary school mathematics. I was not that guy that love numbers. So maybe I will have a delay in calculating 13 minus 5. Okay, so but it's okay. For me, no problem. There is a calculator. I can get out my calculator at any time. So 4 divides 8. Okay, now it's okay. So now 9, I can add 5. And also, if you notice, I removed or subtracted 4 out of 9. This is giving me 5. Okay, just continue by subtracting 4 again. This is going to give me 1. If I check 4 divides 13 minus 1, this is 4, 12, this is true. Okay, so I can have even if I add 4 over 9, this is going to give me 13.
دكتور بس الجواب ما بيطلع 1.
No, I don't. Which one? I don't understand your question. I don't care about the result. I care about the remainder. I just care about this to check this is true. Okay.
Okay.
For example, the 4 can 4 divides 4. It's okay. 4 divides 12. Okay. 4 divides. All the remainders are the same, which are equal 0. So I have here, I can add also, I can add 9, I can add 4 to 9, this is going to give me 13, and 13 minus 13 divides 4, of course, because 0 divides any number. I told you, this is a property of that sign. So 4, 0 is okay. As you know, 0 over, for example, 120 is going to give me 0. 0 over x, anything is going to give me 0. So it's going to work. 4 divides 0. I can add more and more and so on. This is going to give me the same as a cycle or residues. So I can tell you, I have a residue here. It starts with 0. This one is starting with 1. Yeah. Okay.
دكتور.
Yes.
إذا كان الجواب مال القسمة 0 عادي صح؟ يعني مش رقم 0 بس.
Yes, must be 0. This means divides. Divides means the remainder is 0. So for example, 4 divides 12. This means the remainder is 0. No remainder. If you divide 12 by 4, this is going to give me a remainder of 0. I don't care about the result. So just to forget about the primary school mathematics for now. This is totally different. I don't care about the result. I care about the remainder. So here I can have this equation with, they call it class. For example, if I have it like that. So for mod 4, I have this class, which is 1, 5, 9, 13, 17, etc., etc. Okay, and for the opposite direction is -3. Okay, I think -3 is okay. Yes, -7 and -11 and so on. No, not -11. Yes, -11 because yeah, -11. So I have this class, it's called the residuals. The residuals means I can change. If I have a big number here, for example, I have bigger than 9. I can get the smallest number and put it here. So I can remove 9. It's better to remove 9 and put the equation like that. 13 is congruent with 1 mod 4. So I get a benefit of these residues just to simplify big numbers. If I have big numbers here, a very big number here, you know, I can continue for infinity here. So 17, I can continue, no problem. Even for infinity, very big numbers, no problem. I can simplify them by taking their residue and put that number. The smallest positive integer. The smallest positive integer, and I will get the same result. The equation here works exactly as the equation here. Okay? Now I finished my lecture. Do you have any question?
دكتور هذا كله موجود في الشابتر؟
Yes, but the explanation is not like that. I just simplify explanation for you. Everything is found in the chapter.
في examples يعني محلولة؟
Yes, you can have all the information in chapter, but in just compacted, not just the detailed. It's not detailed. If you want the details, you can go to the textbook. The textbook contains many details and many examples. But for the slides, they are very compacted. You cannot understand them without a lecture. Okay, any other question? Any other question?